graph the solution set. For 4t minus 3 is greater than or equal to 9. Now, let's recall the absolute value function. We have that absolute value of x is equal to x if we know that x was greater than or equal to 0 to begin with, and minus x if x is less than 0. So what we can do is we can encompass both cases by rewriting both cases in this function, in this inequality. So we want to write 4t minus 3 is greater than or equal to 9, or negative 4t minus 3 is greater than or equal to 9, right? And now we've encompassed both cases, whether 4t minus 3 is greater than or equal to 0, or if it's less than 0. So now, solving these two guys individually, let's start with the left. So adding a 3 to both sides, we get 4t is greater than or equal to 9 plus 3, which is 12. And then dividing by 4, we get that t is greater than or equal to 3, sorry. T is greater than or equal to 3. So now, on the right side, I want to divide both sides by negative 1 first off. What this is going to do is cancel out that negative on the left side, and on the right side of the inequality we're going to get negative 9. But anytime you multiply an inequality by a negative number, you have to switch the sign. So what we're going to end up getting is 4t minus 3 is less than or equal to negative 9. So now let's solve as usual. So we get 4t is less than or equal to negative 6. And then dividing both sides by 4, we get that t is less than or equal to negative 6 over 4, which reduces to negative 3 halves. So now we have our values for t that it can take. So if you want to graph this on the real number line, well, let's first draw the real number line. Alright, so here's our 0, our middle point, and we want to go out a couple points past 3 on the right. And negative 3 halves is the same thing as negative 1 and a half. So that point's going to be somewhere between negative 1 and negative 2. So we know that t can be equal to 3 on the left side, and it also takes values greater than 3. So t can be equal to 4, it can be equal to 5. In fact, it can be equal to any number greater than 3. So the interval is going to, sorry about that, so the interval is going to comprise of this line that keeps erasing. So there we go. Got it this time. So, oops. And because the line kept erasing, I ended up drawing it somewhere completely different. So let's try this one again, alright? So we want t is equal to 3, and it's also greater than 3. So encompasses all of these points to the right of 3. And we also know that t is less than negative 3 halves. Well, t can be equal to negative 3 halves, which is negative 1 1/2. So we can draw that point here. But t is also less than 1 1/2, so t can be negative 2, negative 3, and in fact any number to the left of negative 3 halves. So this is the representation of the intervals, the closed intervals, of values that t can take.